Hey, good morning. We were out in the observatory at 6 o'clock in the morning looking at Jupiter. I've got the telescope pointed at it right now. There's the ASI 585 MC camera hooked up to my 11-inch telescope, and that's Jupiter. You can see Venus down there. It's coming up too, but right now the telescope is pointed at Jupiter. This is a live feed from the camera. You can see how the atmosphere kind of plays with the image. You can see the moon Ganymede right there next to it. But yeah, I'm making this video because somebody expressed some incredulity about an animation I made. I tracked Jupiter for 5 hours and made a series of images of it to show its rotation. I took one image every minute and stitched them together into a movie, into a animated GIF to show the rotation of the planet. It was a big project. It's not easy to do. I'm gonna play with the focus here, see if I can get it better. It's not a simple project, but it's definitely possible for an amateur astronomer with modest gear. But somebody didn't think I would be able to track Jupiter for 5 hours steadily. And in the old days, people used to have to track their celestial objects by hand with cranks, and then they invented motorized telescope mounts, and that made things a lot simpler because all you had to do was make adjustments. Because even with perfect polar alignment, it's difficult to accurately track an object. But you can see it's staying pretty much, directly in the middle of my screen. And that's because there's a motor in this mount that's slowly turning. And it's making the telescope track the movement of the sky. So it's not difficult at all to track objects for short periods of time. But for 5 hours, you need to get out some digital tools here. Now, I use this software called SharpCap Pro. It's by Dr. Robin Glover, I think his name is. I think it's Robin Glover. He makes this software, and it's free. I don't know. Robin Glover. Yeah, there it is. And it's free to use. It's a fantastic software. So many people in the astronomy community do amazing things for free just because they love to do it. And we're getting some nice detail in the cloud bands there. The atmosphere is pretty stable. I might try to image. But I use the Pro version, and it's for a modest. I think it's like $10 a year or something, extremely reasonable. But it can use some basic machine vision algorithms to send digital signals. The mount is connected to the computer, right? It can communicate via some very standard protocols, and the software can recognize the fact that there's something there on the screen. It's putting an X on it, and then we can calibrate, and it will send movement commands to the mount and see how much the object moves, and it will track it and record how much it moves given the movement commands. And then once it finishes calibrating, then we can just tell it to guide, and it will keep the object right in the middle of the screen for as long as you want. For as long as you can see it's moving Jupiter and recording how far it's moving. Measuring, and then it's still calibrating. It's probably just about finished. There it goes, finished. Calibration successful. You can now start guiding. Okay, now we hit guide, and it'll show where it's picking up the planet, and when it gets too far away from the screen, it'll send movement commands to center it again. So with, you know, a computer, it's a fairly trivial. I mean, it's not trivial. It's a pretty sophisticated program, but it's easy to track Jupiter. And now, which is especially handy in when you've got a big SCT tube like mine, the mirror flops like crazy. So when we're playing with the focus here, where is it? When we're playing with the focus, Jupiter moves significantly because the mirror is flopping up and down as the screws turn. So this guiding algorithm will keep Jupiter directly in the center of the screen while I play with the focus here, which is extremely helpful because I used to have to move it by hand before I figured out how to use this software. And that was a pain in the butt. So hats off to early astronomers who used to do this by hand. You can see it jumping as I'm playing with the focus. Every time I move the focus motor, the mirror flops back and forth a little bit. But the computer keeps sending it signals to keep it directly in the center of the screen. And yeah, it'll do that. It'll keep it directly in the center of the screen all night. Okay, thank you for attending my TED Talk. That's how my computer keeps Jupiter directly in the center of the screen all night long, which is how long astronomers can do it.